we've all taken IT-2400. That's a prereq, right? So you know about DNS. Let's review it a little bit. In ancient days, when computers were on a network together, in order to talk to one another by name versus IP address, all the computers on the network, on the internet, had what was called a hosts file. And so if I wanted to connect to Bob's computer, ping Bob's computer, it would go look in that host file, find its corresponding IP address, and send the packet, right? So that was prior to this idea of DNS. The problem with a host file is it's a flat namespace, meaning there could only be one instance of Bob's computer in that file. Other thing is possible duplicates. We can't have any duplicates. If we do, then that wrecks our system. And the other thing is very unwieldy. As soon as a file becomes, has 10,000 entries in it, and we have to replicate this host file to every other computer on the network, that becomes difficult to manage. Right? Think of an organization that has 10,000 computers. Prior to this idea of DNS, we're using this host file. We have to synchronize the host file on every single machine. We might have 10,000 different entries. That becomes very difficult. So, DNS, yay, came about. We'll review that. So a couple entities involved with DNS. The ICANN, Internet Corporation for Assigned Names and Numbers. Does this look vaguely familiar? Kind of. Okay. And then also the Internet Assigned Numbering Authority is a department or subset of ICANN. And what they do is they manage the top of this DNS hierarchy, and they also manage the global pool of IP addresses. So there's some organizations then that take charge of managing this big registry, DNS. Okay, so first of all, do we need DNS to actually use the internet? No, if I can remember the IP addresses and everything, then we're fine. But that's why we have DNS, is because we cannot memorize the IP addresses of all the sites we visit. So, no, we don't need it. The IP layer of the OSI model just wants an IP address. Okay, so a component then, a registrar. The other day I had you go purchase a domain name. And you went to maybe Google.domains or something, domains.google.com, or you went to Bluehost, or you went to some other registrar. And what they do is they've contracted with their, I don't know if contracted is a good word, but they can go into this global registry and put your address and make everything work. All right? So they put your domain into the global registry. Each top-level domain has only one authoritative registry. Now when we say top-level domain, let's look at VeriSign, for example. So VeriSign is the authoritative registry of all .com, .net, .name, .cc, .tv, edu, gov, jobs, domain names. So no one else, you might be able to go, I could go to Google and buy a joe.com website, but in the end, Google.domains has to coordinate with VeriSign to get your name injected into their table.
I got a .tech one, and instead of going through a different provider, I went directly to the person who was in charge of those.
Yeah. So as I look over here, if this still works, the top level, what was it? TEC?
.tech, yeah, TECH.
.tech? Oh, okay, I'll find out. So we can look here to the global .tech. Who is the people that own that? .tech LLC.
Yeah.
They are the.
That's what I registered with.
They are the authoritative registry for the .tech. Let's look at someone else's. What else do you guys get? Codes. .co?
Yes.
Oh, codes.
Who's in charge of .ninja? That's my real question.
That's me. Meow. Binky Moon LLC.
Yeah, be jealous.
I don't know what that is. Binky Moon, sweet. Anyone else? Look for any extensions there?
Who owns .ninja? This is the real
Oh,
question.
Ninja. Is there a
.ninja? That is a thing, by the way.
Ninja United.
What's .fail?
Nokia owns Nokia Corp. Nokia.
Yeah.
Who would have thought?
Is there a dot fail?
Yeah. Yes, there is.
You just make your own.
Yeah, how do you get one?
Mickey Moon.
Pinky Moon again. I think you just pay a lot of money and you can make your own.
So if I want like a dot Adam, how much do you think that costs?
I don't know.
Of course, Amazon would register .fast.
Did they?
Yeah, Amazon registry services did .fast.
Yeah, I don't see too many like, just, they all look like corporation names here.
It seems like Pinky Moon got all the really weird ones.
Credit. Ooh, credit.
Some of those are so long.
Yeah,
.com thing.
cooking channel.
What?
Anyway, so each top level domain has one authoritative registry. So, you know, we go to these sites. So maybe it's not fair to say that domains.google is a registrar. They're a provider that somehow connects us back to the registrar to put our domain name in that registry.
They may have one or two.
Yeah, I'm sure Google owns a bunch, but. Okay, so let's review this hierarchy. You can't see that great, but at the very top of our hierarchy, we have what's called the root. And then underneath the root, we have some top level domains like maybe .net, edu, org, gov, com. Back when the internet started, when Al Gore founded the internet, right, 1944, there was only like.
That's why they're called algorithms.
That's right. We only had to, when I learned networking, we had to memorize all the top level domains. There wasn't that many. It was like, I don't know, a dozen or something. I don't remember that. So, and then underneath that, we can have a second level domain, and we have like some subdomains, and then finally at the very end, we might have a host within that subdomain. So as an example, if we look at cit.dixie.edu, we know edu is the top level domain, Dixie is a second level domain, and then CIT, I think, we'll just call that a host. Because I can go to the host CIT, that's our web server, CIT. Yeah.
So is that why when you go on like maybe just like free WordPress service, it'll have, if you register your just the first bit, but then it has like .wordpress.com, and all they're doing is adding a new,
Yeah, so we're gonna get to that. We've registered our own domains.
yeah.
So underneath that domain, you can register any subdomain you want,
So yeah.
because you control that domain now. So in the example of WordPress, they own WordPress's domain, so they can create whatever subdomain underneath that they want to. And we'll be doing a lot of subdomains under our existing domain eventually. Other questions on this DNS hierarchy? Okay, so here's a very simple view then of what happened, of this in action. And in fact, let's go back and, what level of OSI model is DNS happening at? Do you remember OSI? What's at the top?
It's
Application, session, transport, network, data link, and physical. So what layer are we dealing with here at DNS? It is an application layer protocol. So when we make a DNS lookup, and we'll talk about that, right? When I type in www.nfl.com on my browser, the first thing that has to happen is a DNS lookup, so we can figure out what IP address that is. So we create a DNS packet, and we'll ignore these two layers because those are dumb. We'll put that packet inside of right, what happens here? This is TCP or UDP. For the most part, DNS happens over UDP. It can switch to TCP if it needs to. And what happens at the transport layer? Well, for when it leaves our machine, we give it a source port, and the destination port for DNS is 53. So we need to memorize that. That's we learned that in 2400, right? 453. And then inside of that, we have our DNS packet. And then we pass that down.